My name is Goutham. I am from Microsoft. I am a cloud solutions architect with the customer success unit. Predominantly what that means is I work with Microsoft enterprise customers to help them to be successful on Azure, basically around architecture, doing a POC, helping them with various design activities or development activities and things like that. Specifically, my area of expertise is around Kubernetes, Azure Container Apps, Azure DevOps, GitHub Actions, and the Power Platform. So these are the 5 areas that I kind of focus in Microsoft. But yeah, let's get started. Let's kind of understand how do we improve our application resilience with respect to failures or disruptions and things like that. So basically the idea is here to give customers or developers or architects or anyone who's using Azure, right, a framework or a platform to help you build your application which are resilient to failure. Now, you don't want to kind of host your application which is like business critical and which is down, right? Even for a minute, you can't be down. So there are like enterprise customers of Microsoft which are like Fortune 500 customers, and they can't afford their application running in production kind of going down. So the idea is like, how do we make sure that your application is running the way you anticipate it to work? And this era is kind of evolving, and yeah, you might have been familiar with the CI/CD era, right, wherein you take the you take the code, you push to cloud. But there is this new wave that's coming in industry, wherein it focuses not only on taking your code, putting it onto the cloud, but taking your code and making sure it is working as expected in terms of how you want your application to run, right? And this is a very interesting area, and a lot of engineering efforts, both from Microsoft side, as well as partners or customers or people like you who would be keen to kind of make sure your application is resilient. So that's going to be predominantly what I'm going to focus on for next 30 minutes, trying to really show you some of the capabilities that we have built in our platform, which will help you to make your application resilient to failures. So let's kickstart. Basically, there are areas where things could go wrong, right? I mean, typically, if you can think of, hardware can fail, software can have bugs, or your application might fail, which is hosted on Azure. And again, most of the times what we have seen is people do mistakes, right? Maybe late in the evening, like you're rolling out something to production, and at times maybe you would have missed something to kind of do a sanity check, and then it kind of went out to production and things like that. So bad things happen. The idea is like, how do you make sure that your application is able to withstand some of those bad things that could potentially happen. But again, bad things happen for a lot of reasons, right? It might be people issue, it might be process issue, it might be something specific to technology or your organization as a whole, right? So the idea is, how do you make sure that your application is kind of hosted on us in a way that you anticipate it to work? And it is always a shared responsibility. I keep kind of talking about this, right? What is Azure responsibility or the cloud vendor responsibility versus what is your responsibility as an application owner or a developer or an architect? How do you make sure your application is resilient to failure? And that's the idea. Basically, we will transparently and openly share with you in terms of how we are making sure our platform is stable, secure, and you expect it to kind of run 24/7. And just to give you some stats or numbers, if you look at a typical virtual machine, the SLA that we adhere for a single VM is 99.95, but till last year, when I say last year, till July 2022, we kind of did an analysis and we kind of got to know that the VM uptime was 99.999, like almost 3 nines, right? So what that means is maybe for a second in a given month, it was down. So that's the kind of reliability we are talking about when it comes to host your application onto Azure. And that's exactly what we are going to cover, right? So like I said, there are shared responsibility in terms of what we build and in terms of what you host on us. Primarily, I'll just first share what we are doing from a platform per se in terms of making sure it is kind of reliable for your applications to be hosted, right? So there is this Azure infrastructure which is like globally spread out, and there are regions and availability zones. I'm sure you would have, I mean, if you have been working on Azure, you know that Azure has got availability zones, Azure has got regions and things like that. So there are other things around data center management and regional network gateways that we kind of adhere, and our processes also, right? Like we don't just deploy a product feature just like that everywhere. It is in a progressive way that gets deployed, and there are right checks and balances. First, it will get deployed to a specific region where it is like a test bed. Then following it is kind of rolled out to other regions. Again, even rolling out to other regions, it will happen in a phased manner, in a progressive way. Like first it gets deployed into a specific a stamp, like just like how Saranya talked in the morning, and then following up from a fault domain and an availability set and an availability zone and a region, right? That's how progressively kind of every product features are getting deployed. And our primary principles are around, again, integrity, security, and reliability in terms of making sure Azure is performing the way it should, and proactive way of reaching out, right? Like you can't reach out when we have like 1,000+ services on Azure. We can't reach out to everyone who is kind of using our services. And one of the ways in which we make sure that that messaging is communicated is via service health. And I'll talk about that service health in some time. But again, the messaging in terms of communicating how you could build your application reliability is again based on 5 communication principles, which I'm going to talk in a while. But yeah, the 5 principles are speed. Like whenever there is a change, you immediately want it to be notified, right? Whether it is impacting to you or not. Let's assume there's a new feature rollout that is happening for any of the Azure services that you're using. How do you get notified? How do you act on it? How do you make sure your application is resilient? And the only way as of today you can do that is with Azure Service Health. So what Service Health does is it primarily captures the changes that are applicable to you, and you will be given a summary of what is that going to impact, whether it's going to be impacting for you and things like that. But yeah, the idea is to communicate as quickly as possible via Service Health. And what I have seen is majority of the times in my customer scenarios, either A, they're not aware of Service Health, or they have not configured anything around Service Health. That will in turn impact their application uptime SLA, right? So the point is look at Service Health and kind of opt for those changes that's happening to your workload, and the accuracy as well, right? So it's important to kind of communicate openly and accurately as far as possible when you're using your application workload. Next thing is around discoverability. Like again, not everything that is going to be deployed on Azure is going to impact you, but there are some things which are specific to your workload. For example, let's say you're deploying a Kubernetes-based workload, which has got few VM scale sets, and like you're deploying your application there, and you have used things like maybe Azure Key Vault, or Azure Active Directory, or Azure Monitor, or Azure DevOps. So there are a lot of building blocks in your solution, right? Now, whenever there is some change, you have to be notified so that you can plan your application uptime, right? So that's the discoverability. Like you will be able to figure out, okay, from past few days or few weeks, what are the services that I have to act on? Let's say there is some service which is like retiring and you want to kind of opt for a newer version. This is the only way in which we can share that detail, and the way in which we do it is like you can set alerts to your email or to your any integration tools that are available in the industry, right? You can integrate to Zendesk or whatever, and then you can kind of act on it. The next bit is around parity in terms of what you see, because of late what happened is I was working with one customer. For them, the Cosmos that they were working had some issue, but they were not able to kind of figure out whether it was their Cosmos which had problem or region-wise Cosmos which had problem. So we will make sure that is kind of transparently shared with you, and with even if there is an outage or anything of that sort, right? You will be given a detailed summary of what has happened. But yeah, that's more around service health and what you can do or what you can expect from platform. But primarily, what is interesting is, or what you should focus on is well-architected framework. I am a cloud solutions architect. I have been in this role for almost 8 years now. And every engagement that I am involved in, I will make sure that my customer or a developer or any team who is going to use Azure understand this well-architected principle, right? So there are various aspects of well-architected principle. I'm sure you would have heard about well-architected principle, but the pillar that I'm going to focus is majorly around reliability today. But yeah, I'm sure there are other talks that you can hook up to kind of understand the well-architected framework in detail. There's also assessment link which I have put at the bottom. Now, if you are on any engagement or if you are working on anything on Azure, highly recommend you go to that particular link which is there. Again, these slides will be made available. Go through all the recommendation in terms of the well-architected principle at the start. I mean, obviously, if you have started, there can be assessment that could be kind of ongoing, and then areas for improvement can be taken and put it in your backlog. But reliability is an area where I am going to specifically deep dive today. Now, when it comes to reliability, right, you have to focus on the first aspect of design. Like I said, if you are starting new, then it is important that you should, like must and should, you should go through the well-architected principle. And even in specifically around reliability, like you should focus on the design aspect, right? How is my application gets deployed? Is it I'm going to use a PaaS service, or is it I'm going to use an infrastructure? Because based on my experience, what I have seen is it's always a combination of PaaS and IaaS things that a customer would deploy. Maybe some database that you want, which isn't available, you spin off a VM, or maybe some feature that isn't available, you spin it off on a VM, or some feature that you want to leverage managed services, you kind of rely on managed services, right? Like behind the scene managed services, we internally in Microsoft, we kind of follow these three pillars, like design, testing, and monitoring. And that is how we make sure that your application, if you're using a PaaS service, it's kind of up and running. Now, the idea is like going through your application, understanding the design recommendations and fixing, right? For example, if I want my application SLA to adhere to 99.99, what are those steps that I have to take in order to make sure that my application is kind of always up, right? So there are different things that you need to do. I have listed few things here, like composite SLAs. Now, composite SLA is like service-wise, you will get an SLA in terms of what Microsoft promises you, right? But there are other things like dependent services that you use. So you have to derive at that composite SLA. There is this thing called failure mode analysis, like you have to kind of look at your application and do a failure mode analysis. Let's say if my Redis goes down, how do I make sure that my application is not impacted? Or if, let's say, any feature or any service that I'm using in a specific region or a specific AZ is going down, how do I make sure my application is still embracing that failure and making sure it is up and things like that? And then comes the testing bit, right? Like there are set of design guidelines. How do I test? The one that I'm going to focus today is on chaos engineering. That's the main area. But there are things like Azure testing checklist, which is again part of reliability assessment that I talked about in well-architected principle that you may want to look at. So let's look at chaos engineering and chaos studio, but primarily whatever I talked about, the design aspect, basically you ask these questions, right? How is my SLI, SLO, SLA going to adhere to my application? But again, like I said, not every application that you develop should leverage a multi-AZ kind of capability or have a DR kind of capability. It's depending on your workload and the cost associated with it, right? Like running a mission critical application obviously comes with a cost. If you have to run same redundant services in 2 regions, that comes with a cost. So you have to basically evaluate what is my application SLA that I want to adhere, whether it needs like 99.99 or 999 kind of SLA, and pick and choose your availability strategy and a DR strategy or a active-active kind of strategy based on the need. Now again, this is something which I just talked about. You have to identify individual components like database, web applications or queues or whatever functionality that you're using, and you have to come up with a SLA, composite SLA. And that gives you a confidence in terms of how do I make sure that I am giving my business back in terms of whatever committed SLA is, right? So again, failure mode analysis that we talked about, like we talked about high availability disaster recovery, like if a specific AZ is down, how do you make sure your application is up, right? Like you spread across AZs. What is disaster recovery? Like you're running in two sites, like a primary and a secondary, and that's DR. And then you want, if there is no high business SLA that you have to adhere, your business is still okay. If there is some failure, you can recover that back from a backup, then you kind of go with the backup strategy, right? But yeah, those are the primary areas that you look at when it comes to design principles. But again, this is something which we talked about, right? Like single isolated VM, it gives you the lowest SLA, but as you move along, right, by putting your application in terms of hardware failure or data center failure or data corruption and things like that, the scope or the impact of that particular failure is going to be more. And there's something called Azure Site Recovery. I'm sure you would have heard about it. It's our DR tool that will help you to kind of make sure your application is like redundant and it kind of spread across different regions. So behind the scene, what Azure Site Recovery does is it kind of replicates your data on an ongoing basis to a secondary site, and that is how you can make sure you can adhere to the RPO, RTO that you are committing for your business, right? But if you are putting it on a single VM that comes with like 99.9 kind of SLA, if you are putting it on availability sets, it comes with 99.95. But if you are splitting across AZ is like 50 miles apart, right? Within a region, there will be data center. Let's assume Chennai. Let's assume Chennai is one city, and the AZ is like anywhere 50 miles apart, the data center will be, so that it doesn't impact any of the common constructs that's happening on a data center level. But in a given region, you can have multiple AZs as well. So that's the last bit. That gives you a better SLA in terms of RPO, RTO that you want to kind of scope, right? But again, everything that I just showed here, right, it's there that you can download. And when you're designing your application, just make sure you're understanding how you're deploying and create a composite SLA and make sure you're deploying it based on the business needs. If business says, I want like 99.9 SLA, it can be kind of going on a single VM. Or if they want little higher SLA, like 99.95, it can go to availability set. If they say 99.99, then you can think of like putting it across AZs and things like that. And yeah, that's primarily about availability zone. This is just talking about availability zone in the region. Like I said, I will share all this with you, but the key thing here is majority of our services, like if you are using managed services, like PaaS services, may it be Redis or storage or any of that sort, right? It is all covered for you. Like we take care behind the scene in terms of uptime. And there's also this capability, like you can opt for it. Like I said, it comes with a cost, right? So some service, if you want, for example, Redis, when you deploy Azure Redis, you can opt for making it zone redundant. Let's say a data center failed, your Redis is still going to be up and running because you have made sure that Redis is spanning across 3 availability zones, right? Or same thing with VM or any of the services that is listed here. So there are specifically zone redundant services that you can opt for, and that's how you make your application zone redundant. And there are some services which are not zone or region specific. There are some services which are like global. For example, Azure DNS, Traffic Manager, and the list kind of goes on, right? So these are by default highly available disaster recovery ready for you, meaning you can't afford it to kind of go down no matter what, right? So those are like some services which are like not specific to zone or any region, but yeah. And then there are services like Cosmos and Redis that I talked about, which comes with that SLA, right, in terms of your uptime and how the Cosmos gets deployed and things like that. And that's where you can bank on us on some of the PaaS offering, right? Like platform takes care of availability uptime for you. And same thing with the services like Redis. Now, depending on the need, for example, you need a caching service which needs like 99.99 SLA, then we highly recommend you put it on a multi-AZ setup. Now, even if you want like higher SLA, like 99.99, you can opt for multi-region active kind of Redis setup. But that again comes with cost, and it is like a zone redundant service, right? So you can pick and choose. Basically, yeah, there is a checklist that I talked about, right? Like I have put that in the deck, you can kind of check. Now, basically testing is very important, and that's what is going to be crucial, right? For any application developer to inject faults in his application and see how it behaves. That's one of the key things. Now, I come from a software developer background. Now, injecting faults was never easy, right? And Netflix, probably you would have heard about Netflix Kiosk Monkey. They came up with a framework where their engineers wrote an automation script which will bring down VMs or EC2 machines on AWS, and then they replicated that kiosk engineering methodology to test their uptime in terms of their application. That's always hard, and what we have done is we have come up with a framework which is based on kiosk engineering. Now, kiosk engineering is basically a set of guidelines or methodology in terms of how do you handle failure. The idea is to improve your application resiliency. Like if you're going or adhering these framework principles in terms of kiosk engineering, you should be able to kind of make sure that your application is always up, right? So there are things like being proactive in terms of identifying or injecting fault, embracing failure, breaking the system wantedly, right? Like you will have environments like a dev environment, pre-production environment, staging environment, and a production environment. You can basically identify failure points, and you can install or you can have a guardrail in terms of how that application behaves. And basically you can minimize the blast radius, right? Let's say there is some impact on your product or your service that you are using on Azure. How does it impact your overall application availability? So the idea of kiosk experiment is again based on the same principle, right? Like you have a baseline, you have some hypothesis, you do experiments, and then you analyze, and then you improve. It's the continuous improvement or continuous validation that I talked about at the start. Basically, kiosk engineering focuses on that. Now, again, you might ask me what are the use cases that make sense in terms of applying kiosk engineering. These are some of the use cases, right? Like, for example, if you're in production or you're in dev environments or staging or pre-production environment, basically you test for resiliency in your workload. Or I work with large retailers, so what they do is they do game days wherein they intentionally try to bombard their system with load, and then they'll try to check for resiliency for their workload. But yeah, why is it important? Like, as I said at the start, if your application goes down, it's not a good experience for anyone, right? Your customers who are using is going to be under tremendous pressure because it's a direct business impact. So you can think of like Amazon or a Flipkart going down, right? Like people are trying to shop, but they're unable to do so. Then what they do is they either end up calling customer care. The productivity of your devs or your team will get impacted because they have to fix something in terms of resiliency. And once the trust is gone, like I'm sure you don't want to kind of go back to a specific vendor who has like lost trust, right? And that's important, and that's where Azure Kiosk Studio, this is very brand new. We just launched it in terms of, it was in private preview. Like we handpicked few customers and we experimented. Now it is in preview. What that means is anyone who's on Azure, they can try this. Azure Kiosk Studio gives you that framework where you can target your Azure services, you can write experiments, you can inject faults, and you can see how your application behaves. Basically, Azure Kiosk Studio has got all this, meaning a set of REST interfaces and experiments and fault library. You can use them and you can inject faults to your application or to your infrastructure or to your environment. So I will show you how this can be done in action. Basically, the idea is go to Kiosk Studio. This is a brand new service, like I said, which helps you to target specific service. Like I said, like you might be using Azure VMs, or you might be using any service like AKS or Cosmos or Redis or anything that you have. You can now target those resources in terms of the failures and the faults. For example, what I can do is I can create an experiment. So I can just go ahead and hit create. It will give you a designer, and what basically you can do is you can go to that designer and you can start adding a fault. Now what are these faults? These are targeted faults that will bombard your Azure resources using the agent or an agentless approach that I just showed you, and you can inject faults. For example, if I click on faults, the list kind of keeps improving or increasing, okay? What you can do is, let's say you are deploying it on Azure Kubernetes service. Now, your pods can be bombarded with the stress, and you can kind of use any of the service like Azure, Kiosk, Stress, or you can even use things like Cosmos DB failover. Saranya was talking about Cosmos DB in the morning, right? So instead of you testing how it behaves, what you can do is you can create an experiment for Cosmos failover scenario in an automated way. So it will automatically bring your Cosmos down for maybe 5 minutes, 10 minutes. It will do a failover from one region to another region. And it kind of talks about, it will help you to create those experiments. You can simulate availability zones, like I talked about availability zones, right? So you can bring down your VMs in a specific availability zone, and you can create those experiments. You can stress test your VMs or Kubernetes clusters with memory pressure, CPU pressure, and all that. So you don't have to wait for production thing to kind of bombard with your stress, but you can inject that via platform now with Kiosk Studio. So I hope that gives you a flavor of what can be done. I'll just show you what I have done in terms of experiments. I go to experiments, I click on experiments. I'll start with maybe CPU based pressure. So it will give you a edit experiment option, like the same experience, but I've already created this experiment. But what I'm doing here is, if I click on edit, I'm picking a VM and I am setting CPU pressure to 95%. So what will happen is that VM will keep getting that stress, and it will keep bumping the CPU of the VM to 95%, and you'll get to see how the VM behaves in such scenario. I'll show you another experiment which I did for AZ failure. So this is a AZ failure scenario. So the idea is, I want to see how my application behaves when a data center goes down, right? So what I've done is, I have created experiment of VM shutting down in multiple ACs. So I have my application. I'll just show you my application in a minute. But ideally what I'm doing is, I am saying this VM, this resource has to shut down for 5 minutes. And how is my application behave when my application is going down for 5 minutes, right? So I'll show you that application. Just for the demo, I created the sample Kiosk web application. Basically, this is using app gateway. There is an app gateway which is like a load balancer, which is talking to multiple VMs in multiple availability zone. So if I go to my backend pool, if you see, I have like 3 virtual machines. Now these 3 machines are split across, these 3 virtual machines are split across AZ. I'll just show you how it looks. So there is an app gateway which is like public facing. This is the load balancer, layer 7 load balancer. Now that has got a route rule which is splitting the traffic across 2 VMs in 2 different AZs. Now what I have done is, I will just, I'll just copy this URL. I'll copy the URL. So if you see here, not sure, just for the demo I was trying to simulate this. If you see here on the top, it says which AZ it is running. Now it is AZ2. If I refresh, it is AZ1, AZ1, AZ2, AZ3. So if you keep refresh, the load balancer will do a round robin across 3 VMs. These 3 VMs are sitting in 3 different data center. Okay. Now what I'll do is, I'll open Kiosk Studio. You guys are getting what I'm showing? There are 3 VMs which are sitting in 3 different AZs. Now I'll kickstart an experiment which will bring down those VMs. Like you saw the experiment, right? I'm kind of taking those VMs down. So if you see, first action is VM shutdown in one AZ. I'm waiting for some time. Next VM shutdown in another AZ. Likewise, all the AZs I'm bringing down. Now I'll run this. I click on start, and you get to see the start summary or the status. Right now it is pre-processing. Once it is done, it will show success or cancelled or whatever, right? But when the fault is injected, meaning when a VM is taken down, how is your application going to behave is what I'm going to show you now. So the first fault is first AZ going down. So when the status changes to ready, right? The same URL, if you hit, right now if you see AZ1 is being shown, and if I refresh, AZ2, AZ3 will load, right? But when my experiment runs fully, right, AZ1 won't get traffic. Although that VM is down, and I can show you the VM here. So if you go to that virtual machine, so the demo 1 is the one VM which the status, if you see, it is stopped because my Kiosk Studio is doing that experiment of bringing down that VM. So this is how you can basically, so if you see, it says running, and if you click on the status, it says this was the VM that was getting impacted and this was the VM which was stopped. But if you see my application, it's still up and running, and it is trying to fetch data from other 2 AZs. It won't show AZ1 because AZ1 is down now. It will get from AZ2 or AZ3, and these VMs are part of availability zone. So if you see, demo VM is running on AZ1. So basically, this is how you create faults or experiments, and you can basically test it. So same thing, I've created a Cosmos kiosk. What it will does is it will bring the Cosmos down, and it will do a failover to another region. You can check how your application is behaving when a Cosmos is failing over. So duration is 10 minutes. Automatically Cosmos will fail over from one region to another region. So likewise, if let's say you want to bombard with CPU pressure, I've created an experiment which will basically bombard that particular CPU with 90 or 95% traffic, right? And then you can view that in your Azure portal. So that's a quick sneak peek of what you can do with Kiosk Studio. Basically, I recommend you to go and try this out because this is one of the important things that you have to do for your workload to be successful in Azure. And we have seen a lot of customers using this extensively now, and they kind of love it because all this was not possible before. Like I talked about Netflix example, right? Netflix engineers wrote that framework by themselves. So it will help you to improve your automation, improve your resiliency by injecting faults in, and it is given by platform, right? Like you can bring down specific services and you can check how it works and things like that. Yeah, the other thing which I highlighted is if you have not done a resiliency review, or if you have already have your application up and running, highly recommend you go through this review checklist, and you should be able to kind of follow that extensive approach of checking the resiliency pattern, right? Then the next thing that I want to talk about is, I kind of touch based on this pattern. Like if you have 99.95 SLA requirements, like you can afford maybe like 1 or 2 hours of downtime, then it's okay to kind of split your workload in an availability set and then get it in a region. For example, in Chennai data center, We don't have AZ yet, but we have availability set. Or you can also kind of go with other approaches, but it all depends on the availability pattern that you're looking at, right? So if you have 99.95 SLA and if you want to architect your solution, we kind of recommend put it in an availability set pattern. Now if you want little more higher SLA, for example 99.99, we recommend you to put it in a multi-AZ setup. This is how it would look like. Your application, if it is running on VMs, the VMs has to be spread across every tier. Majority of the times, what we have seen is developer tend to use managed services. So this is done for you behind the scenes with those services. But if you are looking at infrastructure workload on VM, recommendation is to use highly available data centers in a given region for your application, which has to adhere 99.99 SLA. Now if you want further higher SLA, like I said, mission critical workloads, like it can't afford to be going down. That's where region comes in. You can deploy in multi-region. So redundant infrastructure across 2 regions, or you can leverage something like Azure Site Recovery, which looks at your primary site, continuously replicate. In the event of failure, a switch is going to happen from primary to secondary, right? Or active-active system. So few of my customers are heavily relying on active-active system. So let's say one region goes down due to any unforeseen situation, your business is still not getting impacted. But again, it comes with the engineering cost, right? Now you have to have 2 set of applications deployed on Azure infrastructure, which are like redundant. It comes with cost, it comes with engineering complexity, because the data has to be replicated in another region. You have to handle resilience, and things like that. Yeah, but that's how it typically looks at, like a specific VM workload. If you are using site recovery, you can replicate and put it. But this is what we have seen, right? We have seen people use mix and match of IaaS and PaaS application. So this is one example of how you can think of. So some services that you are leveraging is PaaS, some is IaaS. You can make sure it is highly resilient for failures and things like that. So yeah, thanks everyone.